All right. Hello. I'm Kei Tokunaga. I'm an engineering manager at Fujitsu. Here at Fujitsu, we started working in the Linux community in 2000 and put a lot of effort on enhancing Linux to handle mission-critical applications. My team began participation in OpenStack development back in 2014, and Fujitsu has become a gold member of the OpenStack Foundation since 2015. Right. So when we became a gold member, we made a commitment that we would make OpenStack enterprise grade based on our experiences through development and the support of enterprise and mission critical systems for decades. We have rapidly increased the range and amount of our contributions to the community and became a board member in 2016. So Fujitsu has continually been an OpenStack contributor since Mitaka. Fujitsu has been one of the top 10 contributors by the number of commits of source code to OpenStack. Recently, we have become one of the top 5 OpenStack contributors. And now I'd like to take this opportunity to present some examples of more details of our contributions. This is the first one, and the first one is bare metal provisioning. OpenStack used to only have virtual machines to run workloads. However, some of the enterprise workloads don't really fit virtual machines. For example, database require high performance that physical servers usually provide. So operators had to have OpenStack systems and then also physical servers separately, meaning they had to manage multiple systems, and that was a burden. So our challenge was to unify the management, but by making OpenStack also provide and manage bare metal. But if you just can manage bare metal under OpenStack, it's not sufficient. We also need to provide the same set of APIs and the capabilities, functionalities of virtual machines to bare metal. That's really a unified management, and they really address the operator's burden. Today, we provide bare metal provisioning with features such as power management, multi-tenancy, volume provisioning, and so on. And the next one is non-disruptive upgrades. So there are 2 different requirements for public cloud and the private cloud in terms of upgrades. For the public cloud, we need to provide new features and then also apply fixes as soon as they're available to be competitive. On the other hand, for the private cloud, we usually want to stay with the release as long as possible and want to apply fixes when really necessary to ensure maximum stability. So what's needed for both clouds? For the public cloud, we need to upgrade or update the system as soon as they're available. We can't ask every tenant of the public cloud every single time when you want to update or upgrade. So we need to do it without stopping the OpenStack services. We put a lot of effort on technology called rolling upgrade to make it happen. For the private cloud, after staying with the release for a few years, you eventually have to upgrade to later release. that means you need to do multiple upgrades. And of course, we want to do the upgrades without any downtime. So actually, rolling upgrade can be used for the purpose, and we also need an easier method for multiple upgrades. Otherwise, you need to do hundreds of operations manually. That could introduce some mistakes. So we took an approach where we containerize OpenStack services and automate upgrade processes. Containerizing gives you easier upgrade because all you have to do is to replace the old containerized services. That means rolling back is also much easier. Cola project is working on both containerizing services and also automation of upgrade, of course without downtime. So at the last PTZ, we launched a new SIG, Upgrade SIG. Please join the sessions of the SIG if you're interested. Any feedback are really, really helpful. And the last example is enhancement for troubleshooting. OpenStack has developed many great features, but we can't ignore troubleshooting when it comes to enterprise systems. When a user encounters a problem, then we need to investigate the root cause and provide a fix really fast. Logs are helpful, but they usually just give you an information that indicates something wrong happened. We need more to identify the root cause. For networking programs, knowing how network behaved on the virtualized network is really important to narrow down the point where a problem occurred. So we developed a framework for logging network packets. Today, security group can log network packets. And the features in development are firewall and SNAT. I hope they will be available soon. And for general problems, knowing how the program proceed until a problem happened is really important to identify the root cause. So we took an approach to enhance OS profiler that traces function calling history and provide information such as elapsed time of each function and so on. And so what's next that we're thinking of right now? OpenStack ES or IS core functions are becoming mature. So that figure shows the number of commits to the upstream. People in the community are expanding their effort on things other than the core functions or shifting to new area. OpenStack has a lot of great features, but we did some OpenStack user interviews and surveys, and then the analysis reviewed availability is still a challenge. And their major burdens are maintenance of OpenStack system, not only OpenStack software itself, but OS's servers and so on. Maintenance isn't a frequent operation, but when they do it, it takes a lot of time. And the second one is problem mitigation. Once a problem occurs, they have to spend time, usually a lot of time until the problem is solved or worked around. They also need to have engineers always ready for such an unfortunate occasion. So our idea is to address the burdens or expand the easy upgrade feature to OS and server in the storage as well. With that, basically operators will have to do fewer operations. And auto retrieval is another one to address the burden. When a problem occurs, it immediately and automatically recovers to the point where the system is in operation, minimizing effect to users. Then operators can investigate the root cause later. The second one is enhancement of cooperation with Kubernetes. Today, cloud native is getting more interest and its ecosystem is growing based on Kubernetes. Kubernetes is a great software to ease container orchestration and management. It of course needs computing resources to deploy and run containers on either virtual machines or bare metals. Again, container orchestration can be managed easily, but we should think from the whole system perspective in terms of system management. If you have to set up bare metals or virtual machines manually when needed, it's a nightmare. We definitely need a great software for computing resource management too. And ES can fit the role here. We believe OpenStack is the best choice because it has a capability of bare metal provisioning. People use virtual machines for containers for security concerns, but at the same time, they want to avoid any performance overhead that virtual machine usually give them. Today, some companies and organizations are working on solutions for the security concerns. So running containers on bare metal can become performant and secure. That was an advantage that OpenStack has, and we will make OpenStack be more Kubernetes friendly ES through further cooperation efforts between OpenStack and Kubernetes. Autoscale for Kubernetes is one thing, a single sign-on, volume, file system provisioning for containers, and so on. People won't fully move on to containers yet. They have bare metals and virtual machines on their systems after they migrate some of their workloads to containers or creating new workloads on container. This is something we're still considering, but OpenStack could be one that provide virtual machines and bare metals to users and also bare metals to container as an infrastructure. With one OpenStack, operators can enjoy just one system management. We could even develop a security group across virtual machines and bare metals on OpenStack and containers on Kubernetes. All right, so this is a Fujitsu solution, one of the Fujitsu solutions. OpenStack has become the de facto standard of management platform for cloud infrastructures. However, there are various potential risks yet that can impact timelines and the budget in the implementation phase of a complex cloud infrastructure project. You need to make sure that skilled engineers are on board for the design today, setup, and deployment phases. In addition to it, you also need to take care of maintenance and the ongoing innovation of the complete technology stack. To mitigate those risks, Fujitsu introduced a validated reference architecture for OpenStack. It provides customers with a smooth transition to OpenStack. Please visit our booth for more information. And here's the location of our booth. It's A17. You can ask more details of our activities in the community, products, and the solutions. Some engineers also will be around from time to time, so you can ask more technical details too there. And finally, here's a list of our sessions at the summit. So please visit if you're interested. And so this is all my presentation. Thank you very much.